right, hello everybody. I'm Alex. I'm going to talk about DynamoDB, talk about data modeling with Dynamo, advanced data modeling. Thank you all for coming, really appreciate it. I got a lot to say, so I'm going to jump right in. Agenda today, I want to talk about three things, right? We're going to start off with just DynamoDB basics, get us on the same page with terminology, key concepts, things like that, so we all have the same foundation. I want to do some conceptual stuff just about unique aspects of DynamoDB, how it's different than other databases, and then we'll dive into some practical stuff with a data modeling walkthrough. There's some really good DynamoDB talks this year, really good DynamoDB track. These are two of them that I think are really good. DAT410, this was a senior principal engineer on the Dynamo team and a specialist SA that works with Dynamo talking about data modeling core concepts. So really complements this talk. You know, if this is an advanced talk, so we're going through with some advanced stuff, but really watch that one to get some core concepts and foundations there as well. Also, DAT410, I went to that yesterday. It was really good. This was a senior principal engineer that works on the Dynamo team talking about internal infrastructure of Dynamo, how it's built, architecture, really cool stuff. So recommend watching that talk when it gets on YouTube. Who am I? I'm Alex Debris. I'm an AWS data hero. I do a lot with DynamoDB. I've spoken at reInvent the last couple of years now. I just love Dynamo. I wrote the DynamoDB book, so if you want a comprehensive guide to data modeling with DynamoDB, check that out. And I work as an independent consultant, a lot of stuff with Dynamo, serverless, AWS, so feel free to reach out. All right, let's hop right in. DynamoDB basics. I always like to start off with the same sort of terminology to set that foundation. There are four key terms you need to know with DynamoDB: table, item, primary key, and attributes. I'll show this with an example, and this example will sort of guide what we're going to do the rest of today. So, I do different examples over the years. This year, I want to do a new one. So I'm doing an airline that allows you to book flights, view your flights, view past flights, things like that. So they might have some data about their users or their customers, whoever that's signed up in their application. You can see we have 4 users signed up here, myself and a couple other random ones. All this data is going to be kept together in what's called a table. So table, similar to a table in a relational database, different in some other ways. I think one key difference here is a DynamoDB table is going to be a separate resource, separate piece of infrastructure, unlike a relational database table, right? With a relational database, you have an instance, that's sort of your resource, your piece of infrastructure, and it has multiple tables in it. With Dynamo, each table is going to be a separate piece of infrastructure, a separate resource. If you look at an individual record in that table, say my user record, that's going to be called an item, so similar to a row in a relational database or a document in MongoDB. Now, when you create your table, you have to specify what's called a primary key, and every item in your table needs to have that primary key and must be uniquely identified by that primary key. So you won't have multiple items with that same primary key value. In this case, you can see that primary key on the left. We're using the primary key of email address. That's uniquely identifying every customer in our table here. In addition to that primary key, you can have other attributes on your items, which are similar to columns in a relational database. Big difference being you're not going to specify these up front. So Dynamo is a schemaless database. It's not going to enforce your schema for you other than that primary key that has to be on every item. So you should be maintaining a schema, but that's probably going to be in your application code rather than at that DynamoDB layer. Now, each attribute is going to be typed. You can have simple string types like the first name or the full name, frequent flyer ID that we have here. You can also have a numeric type if you want to have like an epic timestamp or something like that. You can also have complex types like lists and sets and maps, like these user preferences that we have, just a map of different preferences for this particular user. All right, so I mentioned primary key. I want to talk about that a little bit more because primary key is just pretty critical to how you use DynamoDB. When you create that table, you have to specify that primary key, and there are 2 types of primary key in your DynamoDB table. You can have what's called a simple primary key, which has a single element, just a partition key, or you can have what's called a composite primary key, which has 2 elements, that partition key, but also a sort key. Now, the example we already had, that users table, that's going to be an example of a simple primary key. It just has that single element of email that's uniquely identifying each of our records. But elsewhere in our application, maybe we want to keep track of bookings for our user, past trips and flights they've taken with our airline, and maybe we'd use a composite primary key for that table. It could look something like this. Notice that it's that composite primary key, so it has 2 different elements, right? We have that partition key. Again, we're going to use email for that partition key here, but we also have this sort key that's going with it, right? And as you're looking at that, you might notice that multiple records have the same partition key here, right? If I look at these are 4 separate items for that particular user, Alex Debris, but the combination of those two must be unique. So you can have multiple records with the same partition key in a table with a composite primary key, but the combination of the partition key and that sort key must be unique. When you have a set of records that have the same partition key, we might call that an item collection. We work with item collections a lot as you're sort of reading data from a table with a composite primary key in DynamoDB. Now, the thing to note about your primary key is this primary key design is crucial to success with DynamoDB, right? Most of your access is going to be with that primary key directly. And to understand that, you have to understand what's happening under the hood just a little bit with DynamoDB, right? So if you create a table, if you go to the DynamoDB service and make a table, behind the scenes, Dynamo is going to be segmenting your data onto different machines into what are called partitions, right? So splitting up your data, these partitions are usually 10 gigs of size or smaller. So maybe in this table, I have 2 partitions. Maybe my table's 15, 20 gigs here. Now, when I want to write a record to DynamoDB, I do a put item. I specify the attributes, including that primary key. Now, that DynamoDB front end, what it's going to do is look at that partition key. It's going to hash that value and figure out to which partition that item belongs. So in this case, it hashes that value and figures out it belongs to partition 1. And the great thing about this is as your table grows, as your table scales, you can add a 3rd partition or 6 more partitions or thousands more partitions, right? And no matter how big your table gets, that first step is still going to be a constant time operation. So if you have a 10 terabyte table, immediately, right at that DynamoDB front end, it's going to hash that value, figure out which partition to go to, and now you're playing around in 10 gigabytes, right? And that's how Dynamo gives you consistent performance at any scale. So looking at those primary keys, you notice both of them have that partition key, and that's what's doing most of the work of sort of assigning your items to these different partitions on these different storage nodes behind the scenes. And I talk about these partitions, they're mostly opaque to you. You don't really know how many partitions you have most of the time. You don't have to think about it. You don't have to add more partitions or remove partitions. Dynamo's doing that all for you. Let's go look back at our table with that simple primary key. And when you have a table with a simple primary key, you're mostly doing key value type operations, right? You're working with individual items at a time, reading, writing, deleting as you go. So with that simple primary key, only key value operations, working on individual items. Main APIs you're going to be using is that getItem API, which will retrieve a single item for you from your table. Also the write operations like put item, update item, delete item. The important thing to know for these key value type operations is you have to provide that entire primary key, right? You have to know, they want to know exactly which item you want to go update. You can't give it a partial primary key or anything like that. Now, when you have that composite primary key that has those 2 different elements, remember it has those 2 elements, but if we look back at our DynamoDB architecture and what's happening there, it's really just that partition key that's doing most of the work of assigning these records, right? So if we go back to our records and we have multiple records that have the same partition key there, we know they're likely to get assigned to the same partition. And not only that, a bunch of records that have the same partition key, records in the same item collection, they're going to be ordered according to that sort key. That's why it's called the sort key. They're going to be sorted according to those records, to that value, right? So now you can do the query operation. The query operation is a find many, a list many type operation where you can give just the partition key and get a range of records that have that partition key and retrieve those back. And this is going to be super useful. Like in this case, if I want to retrieve all the bookings for a particular customer, all I need is that email address, and I can retrieve all those items without having to know the booking ID as well. Again, remember that's called an item collection. That's what we're operating on here with that query operation. You're operating on an item collection. So if you have that table with a composite primary key, you can still do key value type operations as long as you specify that entire primary key, but now you also get access to that query operation. With that query operation, you're reading a range of items within an item collection. Again, you have to include that partition key. It needs to know which storage partition to go to, but you can also include conditions on that sort key if you want to, right? And if they're ordered according to that sort key within an item collection, you can do things like, hey, put a timestamp in there or something like that. And now if I'm looking up all the orders or the bookings for a particular customer, I can say, hey, give me only the orders for this customer in March of 2023 or before 2021, things like that. So it gives you a lot of flexibility on that. It's really good for list type operations, which can be helpful in your application. All right, so looking back at our table, we know, with this table with a composite primary key, if we want to get a single item, we can do that with a key value type operation. If we have the partition key and the sort key, we can get that individual item, right? If we want to get a set of records that have the same partition key, we can do that, get a range of records here. But maybe sometimes we don't have the partition key available for some of our access patterns, right? We need to access our data in a different way. Maybe in this case, we want to get it just by a booking ID. We don't have the customer email. We only have the booking ID for particular access patterns. How do we enable these additional access patterns if we don't have our partition key, which is doing that splitting for us in Dynamo? And that's where a concept called a secondary index comes in, where you can declare a secondary index on your table. You can basically specify a new primary key for that table. And what they're going to do is replicate your data from your main table into this secondary index. So this is our same data here. We'll take our table. It's going to get replicated into this secondary index. Notice we have a different primary key. This is going to be booking ID. You know, that happened to be the sort key on our previous table, but it doesn't have to. It can be any attribute you want there. And now if we want to retrieve an individual booking item, we can do that just by going to that secondary index. So secondary index, last key term and concept we want to think about there. Again, what's happening is data from your main table is getting copied into this secondary index. It's the same data. It's just sort of restructured. You can use a new partition key, a new sort key for that. This allows for additional patterns, but they have to be read-based patterns. You can't write to a secondary index. All your writes have to go through your main table, and they'll sort of filter out into your secondary index. Now, one thing that's kind of interesting with secondary indexes is you can actually choose which attributes are projected into that secondary index. So by default, you can just say, hey, project the entire item in there, and I'll get the entire item in my secondary index when I want to. But you can also say, hey, just give me the keys. Give me the primary keys for my item, and that's all I'm going to need in my secondary index. Or you can do what's called include, and you say, hey, there's only certain attributes I'm going to need in my secondary access patterns, and now I can shrink those items down. They'll be smaller. You specify the attributes you need with that include, and you have a smaller item. And we'll talk later about how and why that can be helpful. All right, so just a review of the basics here and what you should know from this section. I hope you know the key terminology, right? Table, item, primary key, and attributes. I hope you know the types of primary keys, simple primary key, composite primary key, and what are the implications there, right? Both of those tables let you do key value type operations, but if you have that composite primary key, you can also do that query operation, do list, and fetch a range of records. And then finally, if you have additional read-based access patterns, that's where you pull in secondary indexes and give you, an alternative view of your data, essentially. All right, so let's move on to some unique aspects of DynamoDB, because the more I work with Dynamo, the more I realize it's really a unique database compared to almost any other database out there, and not just compared to other to relational databases, which is very different from, but even other sort of NoSQL type databases, I think it's very different from. So what are these unique aspects of Dynamo? And I think people reach to partitioning first. They say, hey, that partitioning aspect, all that thing we're talking about where Dynamo's splitting up your data across all these different segments and hashing it and figuring out which one to go to, that's what's unique about Dynamo. But anymore, there are lots of databases that partition, right? Like we talked about other NoSQL databases, MongoDB, Cassandra. They partition. I think Dynamo is very different from them. OpenSearch, Elasticsearch, that partitions, and even relational databases now. We have a lot of NoSQL databases, PlanetScale, Yugabyte, TIDB, lots of different databases are using that partitioning and scaling, or that partitioning mechanism to horizontally scale your data. So I actually don't think partitioning is that unique about DynamoDB, or what makes DynamoDB unique. So what does make it unique? I think the multi-tenant aspect of DynamoDB is really unique. So if you create a DynamoDB table, they're not going to go find some instance somewhere and carve off a little slice of that instance and give it to you, and that's your Dynamo table, right? All the users, all the DynamoDB table within an individual region are going to be on the same shared infrastructure, which is really cool. Last year I did a talk with Amrith, who's a senior principal on the team, and he put up this slide which shows the region-wide infrastructure of DynamoDB. So when you create a table, you're using this infrastructure, right? If you have some tiny table, you're sharing the same infrastructure with Amazon.com retail and Disney Plus and Snapchat and Samsung and all these other enormous customers, right? And it's got multi-levels, right? When that request comes in, it's going to hit this giant fleet of load balancers, which are going to handle your request. It's going to forward those to this fleet of request routers, which are responsible for authenticating and sort of handling your request and sending it back, choosing the right storage node, all sorts of things like that. It's got these fleet of supporting services, metadata, partition maps, auto admin, all sorts of things like that. And then it's got this enormous fleet of storage nodes as well behind the scenes that's handling all those different partitions. So even if you create a brand new table in DynamoDB, an on-demand table, you stick like 10 or 12 items in it, it's going to cost you basically nothing. Right away, they're going to give you 4 partitions, right? So your data is going to be stored on 4 different storage nodes. And not only that, each partition is going to have 2 replicas, right? So they're going to replicate your data across all these nodes. So your tiny table 10 or 15 items are going to be stored across 12 nodes in 3 different data centers with all this supporting infrastructure behind it, the load balancers, the request routers, all that stuff, right? So I think that's really unique about Dynamo. And basically, all the Dynamo infrastructure is shared across an entire region. You don't get this little carved out piece. You're working on this multi-tenant system, similar to S3, to SQS, to other sort of multi-tenant systems like that. And I was trying to get the Dynamo team to tell us how big those fleets are, how many request routers are there, how many storage nodes. They won't do it, but I'm going to do some math. I like to do back of the napkin math for a lot of this stuff. And if you think okay, what if I had a 10 terabyte table in DynamoDB, right? Which is a big table, but it's nowhere near the biggest table. In Amrit's talk yesterday, he was saying hundreds of customers have a table of at least 200 terabytes in Dynamo, right? And there are petabyte level tables in Dynamo. So 10 terabytes is a big table. It's not the biggest table by far. If I take that 10 terabyte table and imagine it's very evenly split, so every single partition is exactly 10 gigabytes, that's going to mean I have 1,000 partitions in that table. Each partition is going to be made up of 3 replicas, right? So it's going to take a minimum of 3,000 storage nodes to handle this 10 terabyte table, right? So DynamoDB is much bigger than that. Or if you look at an individual storage node, let's say it can hold 2 terabytes of data. I'm guessing that's conservative. I don't know for sure. So 2 terabytes of data. Again, let's say 10 gigabytes per partition. That means 200 partitions per storage node. So they're going to have tens of thousands of storage nodes. Each one has 200 plus partitions on it. Think how often those storage nodes are failing, and now they have to go make new replicas for 200 different partitions across their infrastructure, right? And everyone loves to quote Werner about everything fails all the time, but this team is living it, right? They have to think about that so much. Failure is always happening, and just think of the work that's happening behind the scenes to make recovery for each of those partitions work, to make recovery for when a storage node goes down or is slow or whatever. They're really thinking about it, right? So again, lots of databases partitioned, but not lots of databases have this sort of multi-tenant architecture for you. So operationally, I think that multi-tenant aspect of DynamoDB is very unique. There are also some modeling, developer aspects of Dynamo that are pretty unique. And one thing is that every index or every request is essentially an index hit. They force you to use an index on every single request, right? If we go back to how we're sort of partitioning data, remember they're using that partition key to split your data across those different partitions. And if we look at the API they expose to you, key value operations, you have to use that entire primary key. You have to use that partition key. It knows exactly which partition to go to and where to start reading from. Or if you're doing a query operation, right, you have to include that partition key again so they know which node to go to and where to start reading from. There is a scan operation. You can use a scan, but these are going to be most of what you do with DynamoDB. And it makes me think of this Twitter thread I saw from Pete Hunt. This is a super smart guy. He helped create React at Facebook. He's the CEO of a data startup now. But he had this Twitter thread on advice for using relational databases and things he'd wish he'd known. And one thing he says is think in terms of indexes first, right? Every time you write a query, you should think which index does this hit. And he has some advice further in this thread about, hey, make sure you're running a bunch of queries and looking at the query plans and making sure it's actually using that index. And that's because in a relational database, there's this intermediary, that query planner, that's taking your SQL query, turning it into a plan, and executing it. But with Dynamo, you're just using that index directly, right? They're just forcing you directly to use that using direct API calls rather than a text-based language like SQL. So I think that second thing, right? They're forcing you to use an index on every request. Another thing that's interesting is it uses eventually consistent reads by default, which I think gets people fired up. Maybe they've had a bad experience with a different database in the past about eventual consistency and worried about that. I think this is actually a good thing. So let's talk about how this works, right? We've been talking about partitioning, how they're segmenting your data into different things. But if we look at an individual partition, that's not just one node, because if that node goes down, now you lose data. So instead of that, within that individual partition, there's going to be what's called a replica group. That's going to be made up of 3 different instances. You'll have a leader node, and you'll also have 2 replica nodes. And they're always sort of communicating. Writes are going from that leader down to the replicas, and they're also sort of sending heartbeats and doing leader elections if necessary for that sort of thing. So looking at an individual partition, what you have, again, is a replica group with 3 storage nodes. Amrit yesterday actually says he doesn't like to say 3 because that could be changing in the future. But as for now, replica group has 3 storage nodes, which is going to be 1 leader and 2 replicas. So this is a strong leader model. This is going to be different from Cassandra, which might not have that strong leader model and then has I think can have issues on writes, right? With Dynamo, since you have that leader, all the writes have to originate at the leader, and it can do things like maintain constraints and making sure certain conditions are true before you're writing that data without going out to have to get consensus from the other nodes, which is really nice. But on the read side, since you have those three nodes, reads can go to any node by default. And by default, it's just going to sort of randomly choose one of those rows, and that's where that eventual consistent read can come in. You can force it to go to the leader and get the most recent version of that data if you want to, using this consistent read equals true. But there are a lot of benefits of using this eventually consistent read. It's actually going to cost you half as much on that read to do that. So I'd recommend doing that in almost all cases. All right, so one more unique aspect of Dynamo, and that's its pricing, right? It uses operation-based pricing, which is just unique, and I think it's really cool, the implications of that, right? So when I talk about operations-based pricing, you're paying based on operations that you perform, not based on resources. You're not going to be saying, I want this much CPU and this much RAM and this much disk and network and all that sort of thing, but you're just saying, hey, I want the ability to do this many reads, this many writes per second on DynamoDB. So when you look at a write operation, they're going to charge you what's called a write capacity unit for every kilobyte of data written, right? So if you have a 4 kilobyte item and you write it, that's going to consume 4 WCUs. If you have a 12 kilobyte item, it's going to consume 12 WCUs. Likewise with reads, it's going to be 1 RCU per 4 kilobytes of data read. So if you read that 4 kilobyte item, that's 1 RCU. If you read a 12 kilobyte item, that's going to be 3 RCUs. And this is where that eventually consistent read comes in. If you are doing that default eventually consistent read, it's actually going to be half price for that. So you don't have, that's actually half an RCU for each 4 kilobytes read. So these are the unique aspects of DynamoDB. And just looking this over, I think one thing that Dynamo does is DynamoDB hides a lot of operational complexity from you, right? And that's that multi-tenant aspect of it, where they have this enormous architecture, and you don't have to think about maintenance and maintenance windows and upgrades and things like that. You don't really have to think about failover in Dynamo. They're going to be doing that. It's very simple to turn on backups and pitter and different things like that. So they're doing a lot of that operational work for you and just exposing it to you as that multi-tenant service. So Dynamo hides a lot of operational complexity, but also it reveals performance costs to you in a way that I'm appreciating more and more as I get more into it. I used to do a lot of SQL and relational databases before DynamoDB, and I felt like I didn't understand what affected performance that well, but I think Dynamo does a good job of revealing to you what is going to affect your performance, right? So if you're talking about that operation-based pricing, they're saying writes are more expensive than reads, and not only that, your operations are more expensive as they get bigger, right? Writing a 1 kilobyte item is going to be less expensive than writing that 100 kilobyte item. Same thing with reading that, right? So you sort of get that feedback loop there. Same thing with that eventually consistent reads by default. If you can handle that eventual consistency, right now you can spread that load across 3 nodes in a cluster. You have probably lower latency because they can go within AZ ideally, probably better availability because if that leader's down, you're not going to have an issue there. And then finally, every request is an index hit, right? They're forcing you to use that index and not just rely on the query planner to maybe do a sequential scan or something under the scenes that you don't realize is expensive, but is going to hurt you down the road. So that's what I love about Dynamo. It hides that operational complexity. It reveals that performance cost. I think the lessons you learn, especially from that last aspect about performance costs, will help you in using other databases. You sort of develop a spidey sense of just this is actually going to be expensive, or I sort of understand what's happening. Even if you're using a relational database or Elasticsearch or something like that, you get a sense of hey, what should I be watching out for and thinking about as I'm doing this modeling? All right, that's the conceptual stuff. We're going to walk through some data modeling aspects here. I'm going to do something a little different this year and do some more advanced patterns. Usually I do just sort of a full access pattern, and we'll start with some sort of easy ones, some key value type stuff, some queries, and maybe some more advanced patterns. I think there's enough good material out there, both DAT410 this year, previous talks, written materials, all sorts of things like that you can get most of those. So I want to do some more advanced ones and think through that. But before we start, just a few principles you should be thinking about as you're working with and modeling DynamoDB. The first thing, if you've read anything, if you've watched anything, I hope someone told you that you should know your access patterns and think about your access patterns before you design your table, right? So it's not like a relational database where you sort of normalize your data first and then think, how am I going to access this data? With Dynamo, because it's forcing you to use those primary keys and that partition key, sort key concept, you want to structure your table so that it can handle your access patterns, right? You want to think, what is going to be meaningful? That's what I want to put in my primary key so I can access it. And this can be hard for folks but I think you really get better at it pretty quickly. I say if you're new to this, I'd really go out and be explicit and write this down and sort of discuss this with your team. It can be part of like your planning and modeling type step, right? Be explicit about writing out your access patterns, both your write access patterns and sort of like what conditions do we need to maintain, frequency, things like that, but also your read access pattern, right? How are we going to be reading our data? Do we have any filters on that? Do we have an index? Are we going to be doing like a key value operation or a query operation? What does that sort of look like, right? So be explicit on things like that, at least your first couple times. In addition to knowing your access pattern, more and more I've told people, hey, make sure you actually know your domain pretty well. Because with Dynamo, you are sort of becoming the query planner in a way that you're not in the relational database, right? You have sort of lower level access on some of that stuff, but you can sort of think about that, and ideally, you get that direct access to the indexes basically, and you think, what's the most efficient way to do this based on my domain? And when I talk about knowing your domain, I say, like, what are your constraints, right? When you're writing, storing data, you probably have some limits you want to maintain in your application, or you want to maintain uniqueness somewhere. What are these constraints you want to maintain, and how are you going to structure your item so you can maintain those constraints? Likewise, you want to think about your data distribution, right? We talked about item collections. You might have multiple records with the same partition key. Like, how many records are going to be in an item collection? How big is that going to be? How is that going to affect pagination and things like that, both in my application for the API for users or different things like that. And then think about how big are your items, right? We've seen that the bigger your items are, the more it's going to cost in terms of write consumption and read consumption. So think about that, and then you can be a little more strategic about different patterns for that sort of thing. So know your access patterns, know your domain, and then know the DynamoDB basics, right? We've gone through the high-level stuff, but really get to know the Dynamo API, because again, you're going to be using that API directly. You're not writing a SQL query that's going to get processed and parsed by someone else, but you're actually doing like specific methods, right? You have these single item actions for your core operations where you're working on an individual record, retrieving an item, updating an item, deleting an item, different things like that. You also sprinkle in that query operation because you have find many list type needs in certain cases. When you need to get fancy, then you can pull in like batch and transaction operations. Dynamo supports transactions. We'll talk a little bit about that later today. So you can use those things. But really, those single item actions, those queries, that's going to be the bulk of what you're doing in Dynamo. And again, I'm not going to talk directly about some of those, because if you look through these access patterns, I'd say like a lot of these access patterns are pretty straightforward. Like these write access patterns, you're often creating an individual item. Maybe you need to maintain uniqueness. Maybe you're doing an update that has some constraint you need to do, but it's pretty straightforward. It's an individual item action, pretty straightforward to handle. We're not going to cover that today. Same thing with these read access patterns. A lot of them can be handled straightforward with a get item or a query operation. We don't need to think about that sort of thing. So I want to talk about 3 sort of more advanced patterns. They might not be directly applicable to your use case, but I think what I want you to get out of this is like how to approach the problem, especially when you can't just use a simple get item or a query or different things like that. How can you approach this problem, think about your domain, and make it work for you? All right, so the first pattern we're going to do is search flight options, right? So when I came out to reInvent, thinking back in June or July, I was like, I need to fly to Las Vegas, right? So I went to a site probably like this, and I typed in, I'm from Omaha. I was like, hey, I need to go from Omaha. So I have my origin, I have my destination, Las Vegas, and I put in the dates that I want to get. And now that site needs to go and say, hey, what are the different options for that particular date, right? And you might think, hey, this is not that hard of a problem. I could jam it all together like this. Maybe I have a partition key that's route by day, right? And I have, in this partition key, I sort of have this jammed together key value here where I'm putting those different attributes in there, right? I put my origin airport, I put my destination airport, and I put the day in there. Now I can do that query operation, right? Just give it that partition key, and I have all the different flights on that day, and I can show them, hey, which one do you want based on that departure time? And you might think, hey, that's pretty straightforward and easy. Why are we doing that here? But with most flights, you don't have a direct flight, especially if you're coming from Omaha. You have to route through somewhere else, so maybe you have to route through Denver or Houston or something like that. So knowing our domain, we can't do this straightforward, just sort of lookup type thing for direct flights, because it's not always going to be a direct flight. Sometimes there's going to be a connecting flight, right? So let's think about knowing our domain. What do we know about our domain that can help us sort of model this thing, right? First of all, we know there's not always a direct flight. Sometimes we need to do connecting flights between that. And you might think, hey, how many different options can there be? Maybe I'll just like pre-generate all these things so I can still do that sweet key lookup based on that query and get those different options. So you look it up, and like the larger airlines are doing 5,000 flights a day to 350 airports. So probably not going to work for you to like pre-generate all these different options for you there. So you don't want to do that. And now you're thinking, oh man, what do I need? Do I need like a graph database? Do I need something super fancy like that? Well, knowing your domain, most airlines have this hub and spoke type model where maybe they go to 350 airports, but like 6 to 8 of them are handling most of that traffic. That's what most of the stuff is getting routed through, right? So that's the domain we're working with this particular airline. So how could we approach this problem and handle this particular problem? Right? So just thinking about the steps we would do, what's the algorithm we would use? First of all, find any direct routes between those airports there, right? You could just do what we were doing before, and if there is a direct route, we'll go and fetch those and get those back, right? So that helps. But now we also need to generate the different connecting options that we have for this. Right, and so what does that look like? Well, first of all, if our origin's not a hub, maybe we find rights from that origin to a hub, right? So we go out and we look at Omaha to Denver, Omaha to Houston, things like that, and just fetch those sort of candidate options. We're just holding those. And then if our destination's not a hub, we'll do the same thing. Find the routes from that hub to the destination. And if neither ones are hubs, we'll find the routes between these hubs. So now we're holding in all these different sort of flight options. And then based on that data we're holding locally, now we can sort of generate the different paths that are viable through these hub and return these candidates, right? And that seems like a lot of requests. So one thing I say is like, let's do the math, right? And one thing I love about Dynamo, with that operations-based pricing, you can do the math, figure out how much this is going to cost. Like, is it worth it to do it this way? So let's do the math. I'm going to go through this slide pretty quickly. Don't feel like you have to keep up and like check my math on this, but just believe me that it works out. Or if it doesn't, hit me up afterward and we'll figure it out. But let's say that flight item record is 1.5 kilobytes. I don't know how big a flight record would be. I want to fetch those direct connections, right? Maybe there's about 2 direct flights between airports on average. That's going to be about half an RCU to do that. Now I want to fetch the origin to the hubs. Let's say there's about 4 flights from an airport to a typical hub. We have 7 hubs. That's going to be 7 different query requests. It's going to cost us 7 RCUs for that. Same thing with hubs to destinations there, right? 4 flights times 7 different hubs, 7 more RCUs. So this is going to cost us, let's say 14.5 RCUs, just to like sort of get these sort of candidate airports, right, across this sort of thing. And if you're like, hey, 14.5 RCUs, is that expensive? Is that not expensive? On-demand mode, that's going to cost you about $0.25 per 70,000 executions, right? And so like probably not that bad for you to do this. Like generating flight options between these things, you can do 70,000 of them for $0.25 here, which I think is fun that you can like calculate that sort of thing out. But I wouldn't stop here too. Like this is like a very database heavy option. I think, hey, is there a better way? Could we do this a better way? One thing I don't like about this is like it's making a lot of requests to Dynamo, right? We have that initial query for our direct flights and then 7 queries for each hub on both origin and destination, so 15 different queries overall. Is there a better way to do this? Thinking about this sort of problem here, we have this flight item record, right? And it's 1.5 kilobytes, but to generate our candidate options, we don't really need all that data, right? Let's tear apart our flight item record. And it's really 2 different pieces, right? It's this static data that's just the route data. It has origin, it has destination, it has date, departure time, very small amount of data, and also it doesn't change. And that's all we need to like generate these options, these connecting options to get from Omaha to Las Vegas, right? We just need sort of that data. And then there's more dynamic data like the current flight status, right? Are there seats available? Is there, what's the price for these seats and different things like that. So we only need that static data. That static data is very small. Like, do we need a database for that, right? So now we can think about this, doing the math part 2. What if I just had my sort of flight metadata records and I had these all locally on my compute machines, right? When my container or whatever it is spins up, I just download like, the next 6 months of data of just like sort of candidate options here. How much data is that going to be? So maybe that's 100 bytes per record, which is probably, that's pretty generous there because we're only it's only a few pieces of data we've got there. If we're doing 5,000 flights per day, that's 50 kilobytes. Let's say we got the next 6 months of flight records here. That's going to be 9 megabytes. So for 9 megabytes, I can have all the flights that are going to happen within my airline for the next 6 months. I can just download that onto my compute. And now when a request comes in, I just brute force it, go through that data, figure out which I want. And once I have my candidate records, maybe I have 10 routes with 2 legs per route, so I need 20 flights. Now I can go fetch those from Dynamo using getItem and see, hey, are there seats available? Which seats are available? What's the pricing on that sort of stuff? And now I'm down to 10 RCUs to do that, which is cheaper. It's not a whole lot cheaper, so that gets you 100,000 executions per quarter, which is nice. But also, you're just doing less on Dynamo. You're not doing all these requests to Dynamo. A lot of that data is pretty static, so you can keep it closer to your compute and only reach out to Dynamo when needed, right? So this is kind of like a unique, weird situation. But the high-level points I want you to take away from this is not all your problems are going to break down neatly into database queries. A lot of your stuff will be those individual item actions, will be that query operation. But then when you have a hard one like this, right, which is a graph problem, how can you sort of do that knowing your domain, knowing what changes and doesn't change, and get you a solution that really works? So use that domain knowledge to find a solution that works. And as you're doing this, do the math. I love that Dynamo, you can do the math and figure out how much this is actually going to cost you. Is it feasible for our use case, and is that what we want to do? All right. So that's one pattern. Now that we know our flight options, let's book this flight. So this is a write pattern. And on write patterns, you really want to think through your requirements, right? What are the constraints you need to maintain? What's that sort of flow that needs to happen to make sure we're actually saving valid data here, right? So some of the requirements here, we only want to confirm this booking if seats are available. So if I'm going through this flow and I want to sit in row 7F or whatever, I only want to book that ticket if I can actually get that seat on that flight. But also, if you go through these flows right now, you don't always have to choose your seats when you're booking. You can just book a flight and say, I'll book it later, right? Choose a seat later. So you can do that. So you need to sort of maintain that option there. Also, a flight can contain multiple legs, as we've seen, and we sort of want that as an all or nothing type of operation. I don't want that flight from Denver to Las Vegas if I can't get from Omaha to Denver. And then after confirming that flight, we might need to do certain things, right? Like credit their frequent flyer points or do other types of operations, right? So those are the sort of high-level requirements here. Let's talk about maintaining constraints first, and then we'll talk about sort of these harder flows that we're working with here. So maintaining constraints. When I talk about maintaining constraints, I say you have certain limits in your application that you want to make sure are maintained before accepting new writes, like making sure that seat is available before you book it. So to do that, all write operations allow what's called a condition expression. So when you're sending a write to DynamoDB, you can say, hey, make this write operation, and you can include a condition expression that describes the current state of the item or holds some conditions, right? And if that condition expression evaluates to false, that write's going to be rejected and sent back to you. So in this case, imagine we have our flight options here. We have those routes by day. We might have something like this claimed seat map, which is just a map of the different seats on this flight. When someone claims it, then we mark that seat as taken by this particular flyer or booking ID or whatever we want to do there, right? So we're using that. We're making sure that's not taken. So first step in Dynamo is make sure you're using condition expressions to maintain these constraints. Second level, like Galaxy Brain, is hey, make sure you structure your items in a way that allows you to use condition expressions to maintain those constraints for you, right? And one thing you want to avoid is the read, modify, write cycle, where maybe you have to read an item to get it back. You have to perform some checks locally to make sure all those constraints are met, and then you write it back. And now you have to do a versioning scheme and all sorts of different things like that. But what if you could just do that write directly against your database? So going back to our flight options, they were talking about here, we have that claim seat map that allows us to make sure that seat is available for a particular person. But maybe we also have this other attribute, which is the held seats, right? These are the seats that are, someone's paid for, but they haven't chosen their specific seat. They just know they want to be on the airplane, right? So we're using that in our held seat. The problem here is we have this total seats attribute as well, but you can't do a operation against Dynamo that sort of checks to make sure there's at least some seat available in this sort of thing, right? Because basically what you have to do is say, take total seats, subtract held seats, subtract the number of claimed of seats in that claimed seat map to make sure there's at least some seats left on this flight, right? So I wouldn't set it up this way. When I talk about structuring your items so that you can do these direct operations, what I would do is have maybe an available seats property as well, that you're sort of maintaining that purely for the purpose of doing maintaining these constraints in Dynamo, right? And this means you need to think through the workflows, how your item's going to get changed throughout this stuff, right? You can imagine someone comes, they want to book a ticket with specific seats. Well, what does that look like? they're going to perform some updates. We're going to update the seats in that claimed seat map. We're also going to decrement the available seats on our flight overall. And then for our conditions, we're saying, hey, make sure that the seats we're choosing in that seat map are available, but also that the available seats is greater than or equal to the seats being booked as part of this operation. Right? And if the second person comes and they want to book without specific seats, we have a different set of updates. Right? We're incrementing those held seats and decrementing the available seats. And our only condition that we need here is making sure that the available seats is greater than the seats booked. And then finally, when that person comes back later and chooses their specific seats, right? Now we need to decrement the held seats because they're not held anymore, they're going to be claimed, and we want to update the seats in the claimed seat map and make sure those are currently available. And the only condition expression we need there is knowing that those seats we're choosing are available. Right? So think about like how do I structure my item so I don't have to do that read, modify, write loop. You can just do that update operation directly against DynamoDB because you have that available seats property. All right, so going back to our requirements, we had these requirements around, we only want to confirm that booking of seats are available, including just like general seats that aren't specifically chosen, right? That's where you want to use condition expression. That works really well. We also have some harder things, right, where a flight can contain multiple legs, and then after a flight's confirmed, we want to do some other things, right? So let's walk through what is this full flow of operations we need to do when a flight is booked, right? First of all, we want to make sure we reserve seats for all legs of the flight. Make sure that those seats are available when we book those. If that fails, we're going to reject it, send it back to them, and say, hey, either there's no seats left on it, or the seats you chose are not available, choose some different ones, different things like that. Once we reserve those seats, maybe now we need to process the payment for that flight to make sure they actually are giving you a valid credit card for that sort of thing. This is probably going to be an external system. And if this fails, we want to roll back those seat reservations. We want to reject those bookings so now those seats aren't taken for a customer that does have a valid payment method, right? And then we want to do something else, create a trip record, credit frequent flyer points, different things like that. So whenever you hear, I want to do multiple things as part of a step, right? What do you think of? You think of transactions. Dynamo has transactions. It's supported transactions since 2018 now, I think, 2018, 2019. Just like relational database, what you're doing is you're processing multiple operations in DynamoDB in a single atomic request. It's all going to sort of succeed or fail together. A great thing about this is each operation can have a condition expression. So if you're booking a flight that has 3 different legs in it, if one of those fails, it's going to roll that whole thing back, reject it back for you, and you're not going to book 3 of those legs, but not the 4th one. However, you can't do long-running transactions. One thing that's different about DynamoDB transactions as compared to like a relational database transaction. Relational database, you can say begin transaction, read something, go fire off something to an external system, go call some other service, whatever you want to do there, come back, commit some data, or write some data and commit that whole transaction or decide to roll back. Dynamo doesn't let you do long-running transactions, right? You can only do sort of single-shot transactions where you assemble all the changes you want to make to your items, send them over as a single request, and it's either going to accept or fail on that single request there. And that takes a little flexibility away from you, but it keeps that guarantee that Dynamo has around consistent performance at any scale, where you're not going to have a deadlock or anything like that where you're waiting on this long-running transaction and it's blocking a bunch of stuff. So if we go back to our full flow that we need to do here, all these different things, we can use DynamoDB transactions for part of this, right? When we're reserving those seats in our flight, that's a great operation for DynamoDB transactions. We're manipulating multiple records, and we want to make sure they sort of succeed or fail together. Our other one, we have an external system that we can't sort of wrap in a transaction. So how do we do something like that? And that's where you need to look into, client-side transactions, manage that yourself, or you could use something like AWS step functions, right? Dynamo integrates really well with the rest of the AWS ecosystem. So you can use something like step functions to manage the rest of that transaction. So maybe you have a state machine definition like this where you're using DynamoDB transactions as part of this, right? That first step where you're updating multiple records in DynamoDB as a single request, you can do that together. You can reserve those seats and make sure they happen. You check to see if that's successful. You fail. If not, otherwise you keep going, and maybe you call out to a Lambda function that handles your payment. If that fails, then you go and roll back that reservation. You sort of unreserve those seats that you have and fail that thing. Or maybe you go and succeed or put an event on EventBridge or something different like that, right? So the big takeaways I have just on that's kind of a complex write operation. I think there are a couple takeaways here. Number one, use those condition expressions to maintain your constraints. You have to use those. That's going to be really efficient for you to maintain those constraints. And it's not going to cost you anything. It's not additional latency costs. There's no sort of coordination that needs to happen as part of that condition expression because of that single leader model. It's not going to cost you any more or anything like that. And then as part of that, make sure you're structuring your items to allow for direct operations against your items. If you need to work with multiple items in a single request, that's where you can use that transact write item operation and get you that sort of atomic nature where it either succeeds or fails together. But just note, like there's additional costs for that. There's additional latency because it's two-phase commit, so there's a little bit of chatter within the DynamoDB system. And then also it's that single-shot transaction where you can't have a long-running transaction where you're going to do other things. If you need a long-running transaction, that's where you need to look at client-side transactions and step functions and things like that. But really limit and avoid that where possible, right? You want to eliminate that coordination that needs to happen, right? That's where you're going to get issues in your application. Sometimes that's necessary, but see what you can do there. And then finally, if you want to do additional work sort of reacting to these things happening, that's where you use EventBridge, you use DynamoDB streams to react to these for asynchronous things, like creating a trip record for that particular user, right? Once they've booked those flights or updating their frequent flyer points, that doesn't have to happen as that part of that initial flow. You can pass that off asynchronously. All right, so that was our second sort of unique pattern. All right, last pattern I want to talk about here is complex filtering, because this is the question I probably get the most from people is how do I do this in DynamoDB? I don't know if this is the real name for it, but I call it complex filtering. When it's filtering on 2+ attributes, each of which is optional, right? So if I'm giving a CRM, one of you signs up for a CRM, has a bunch of customers in there, there's a bunch of different filters or fields that you want to filter by. Industry, size of company, location, role, are they a customer or not, all these different things. You want to filter on those, and all of those values can be optional in your filter, right? That can be a hard problem in DynamoDB. And the reason it's a hard problem in DynamoDB is, again, every request is going to be an index hit, and this is kind of a hard problem to do. I think the first thing people reach for is they jam a bunch of values into their sort key, which can be useful. Sometimes you can have multiple values in your sort key and allows you to filter at different levels. But it's like a composite index in a relational database, right, where you have to follow a bunch of different names, but the left prefix index rule, right, where if you have a composite index in your relational database, it basically gets evaluated left to right. So if you have multiple values in your index, it's going to get evaluated left to right. You can't have any gaps or skipping. So if you have 5 values in there and your filter does not include the second value, it's going to stop using that index there and basically get just the rest of that, and up to including the first range, right? So if you have a date range or something like that, your index is basically blown at that point, right? So that's going to be true for Dynamo. You can go check out this at Baron Schwartz, really good MySQL guy, if you want to know more about that. But if we were talking about our bookings and maybe we want to allow people to filter by origin, destination, fare class, and things like that, you might think, again, hey, let's throw that all into a sort key and give all those values there. But that's only going to work if people give me the origin, the destination, and the class, or at least the first couple of those. But as soon, like if someone does not give me the origin, this sort key is not going to help me. It's just basically going to have to get all the records there. So this is a hard problem in DynamoDB. It's much easier in SQL, where it can do a query planner, do index intersections, and read from multiple indexes and sort of figure that out. But how do we handle this in Dynamo, right? And then it comes down to knowing your domain and doing the math, right? We've been building this muscle. I hope we can use it here. So let's know our domain and do the math. Let's walk through a few different categories of complex filtering within our application, see how to handle these. Right, so we have some read access patterns, and let's say we want to do search bookings for customer. So as a customer, right, I have all these flights that I've been to in the past, and each of these flight records is going to have these attributes on it. Right? It's going to have a flight ID, origin, destination, fare class, right? And we want to give people the ability to filter on their past flights and see what's going on here, right? So this is our first example here. Our goal is to enable users to search bookings with many optional filters in that sort of thing. And as I said, let's do the math. So let's think about the math on this sort of thing. How big is a booking record? Let's say maybe 3 kilobytes. That's probably generous. It's probably smaller than that. Let's say 3 kilobytes just to make it harder. If we think about this like 90% of customers are going to have fewer than 20 bookings, right? I fly a decent amount. I use different airlines. I'm guessing I haven't flown more than 20 times on most of those airlines, right? So 90% of your customers are going to have fewer than 20 bookings. So if you do the math, and I just fetch all those records, 20 bookings times 3 kilobytes, that's only 60 kilobytes of data. You divide that by 4, that's 15 RCUs. You take in half for an eventually consistent read, that's 7.5 RCUs. That's just like not that much data that you have to read from DynamoDB. That's not going to kill you. So what you can do if someone wants to do this complex filtering access pattern is just fetch that entire item collection and do that filtering, after you read it from DynamoDB, send all that data to the browser. You can do that filtering in the browser. You can see this pattern a few places like within AWS. If you go to CloudWatch logs and you want to search like CloudWatch logs names, what they're doing is just like fetching all the names in the background and they're doing client-side search on that in the text box, right? Same thing with step functions. If you're in step functions, want to find an execution ID, they'll fetch the most recent 1,000 for you and allow you to search for that. And it's all client-side filtering. If you do this and are sort of fetching that whole thing, the big thing here is you want to watch the tail, right? Like I said, probably more than 90% of customers have fewer than 20 bookings, but I read this article sort of recently about how airlines used to give like lifetime passes to people, right, and regretted it. So this happened like in the 80s. One guy recently took 373 flights in a single year, so he's probably been doing that for like 30, 40 years now. He's got thousands and thousands of flights. If you tried to fetch his whole item collection, like what's that display page going to look like for him? You have to think about like what's my tail look like, and is that acceptable? Is it going to be just an expensive experience for us to handle that, or are you just going to have a degraded experience for him? So think about that sort of thing if you use this pattern. But the first pattern, the easiest pattern for complex filtering, is just do overfetching, right? Fetch that entire item collection or relevant item collection, send it back, and do that filtering in the browser or wherever you want to do it. This is going to work well when your overall target data set is small. And I'm saying target data set here, not your entire data set. So you could do this with all your customers. It could be 10 terabytes of data, whatever. But if me, personally, as the 90th percentile customer, I'm only going to have 50, 60 kilobytes of data, you can fetch that. So that's the target for a particular query that I'll be filtering on with this complex filtering, right? So if that's pretty small, just do that overfetching and be done with it. All right, let's take it up. Example 2. Same thing, but now we want to do it at an organizational level, right? So let's say that all these bookings are done, every customer can be associated with an organization. We want to now allow organizations to search these bookings, right? So if we have all those bookings there, maybe we have this organization column as well. We set up a GSI for that allows us to get all these bookings for a particular organization, right? So this is our goal. This messes up our math, right? Because we still have that 3 kilobyte booking item, but now we have 500 employees, let's say, with 20 bookings each. If we do the math on that, now we're talking 30,000 kilobytes. It's going to be almost 4,000 RCUs, even with an eventually consistent read. That's not something I really want to be doing with there. So how can we make this better in this point? One thing I would say is, again, look at that item we have. It's a 3 kilobyte item, but most of that data we're not filtering on, right? Maybe we have 5 or 10 values we want to filter on. Those are like string values that are pretty small, strings or enums, very small amount of data there. Remember I talked earlier about secondary index, right? You can choose which attributes are projected into that secondary index. And let's see why that could be beneficial for us. And just thinking about projections generally, like what are the benefits here? Big ones are going to be like, it can reduce your item size so you just have smaller RCU and WCU consumption on that secondary index. It can also reduce your WCUs by avoiding writes to the index altogether. So if you have some item that you update, but you don't project those updated values into your secondary index, it's not going to touch your secondary index. It'll just skip that write altogether. The downside of having like a reduced projection on your secondary index is you just have less schema flexibility, right? If you add new attributes to your items, they're not going to be included in that secondary index production definition. They won't be replicated into that secondary index. It can lead to like a follow-up get item request, like maybe you query for some items from your DynamoDB table, and now you need to like hydrate the full record by doing a get item, things like that. But I think it can help us here. So we have a 3 kilobyte item. What if we only replicate the data we need to filter on into that secondary index, right? And let's say 200 bytes, that's probably being generous. I think it's much smaller than that. But let's say 200 bytes get replicated into that. That changes our math quite a bit. Now we're only doing 2,000 kilobytes to fetch an entire item collection for this organization. It's 250 RCUs. That's still higher than I'd like to see, but maybe it gets us in sort of the range of reasonableness. You can see that, hey, these secondary index protections can be a really nice way to help filter your data for these sort of list filter type operations. So our second option for these complex filtering is, hey, use that reduced projection into a secondary index. This is good when you have those larger items, but a smaller amount of filterable attributes. And just to extend both of those options there, another thing you can do is, like, how do we reduce this search space even further? Right? I'm talking about that target space you're hitting for a particular complex filtering thing. What can you do to reduce that search space? You can require some attributes, but not all of them. And this can help if that attribute you require really does filter down your space, right? So for example, include a date range on your as a required filter. And now if a date range is in your sort key, now you can say, hey, only get the records for this particular date range. That can really cut it down, and now you can do filtering a lot easier there. So maybe, yeah, again, if you use that sort key with a date range in there, that can help you out. So again, another strategy, how can you reduce that search space, require that attribute that's useful for filtering? So those first two options are both like Dynamo-specific options here, but sometimes like Dynamo is just not the right tool for the job, right? Sometimes you have a really large target data set that you need to do some complex filtering through, and it's going to be hard to model that in Dynamo. So examples would be if we extend that organization search out for really large organizations, 5,000, 50,000, 100,000 people, that's just going to be really big to fetch all those and do that filtering on the client side. You can also think of filtering of like a really large product catalog like Amazon.com, right? There's just a lot of products in there that we need to filter through. Also just full text search, which is like complex filtering taken to the max, right? Because now you're filtering on every single letter basically on a corpus there. So in that case, that's when I recommend people reach out and look to external purpose-built systems for this. I'd say the two that come up most commonly are going to be OpenSearch, Elasticsearch, things like that. Rockset is also like another third-party one that I really like. I recommend to a lot of people, hooks in your stream and indexes that data. But basically some sort of purpose-built system for this particular thing, right? So now you're pulling in external system to handle some aspect of your application. There's just a few things I tell people when they're doing this is, like, remember, you're adding another operational burden here. You're adding another piece of infrastructure that you're responsible for. It's going to affect your availability and uptime. So just think about that and that aspect of it. My biggest tip here is like keep it as small as possible. Like Dynamo is really good at those individual item actions, the query operations. Do all those in Dynamo, and now you get this really nice operational benefits from doing that, and only farm out to Elasticsearch or whatever those harder operations. And one thing I see people get stuck into is they start to use Elasticsearch for something, they like that, now they have a new access pattern. It could work for Dynamo, but it'd be a little bit of work, so they're just like, hey, let's use Elastic for that too. And now Elastic gets bigger and bigger, you're doing more requests on it, and now it's like a nightmare, and if that thing goes down, like you're in trouble, right? So keep it as small as possible, stick to Dynamo where you can for those things. One thing Dynamo has really changed, like since I got involved with it, is just like integrating with other tools. They've made it a lot easier to get data in and out of Dynamo into other systems, right? So DynamoDB streams, that's been there for a while, where you basically get a change data capture on your data, and you can just process that in real time and go feed your Elasticsearch, OpenSearch cluster, something like that. But they also have export to S3 now, where you can say, hey, take my table and create an export of it and dump that entire table on S3. And if you're sort of bootstrapping a new Elasticsearch cluster, that's how you can do that. Do that initial dump, ingest that into Elasticsearch, and now read from DynamoDB streams to keep that up to date from going forward. And they also have incremental export now, which is really interesting. So you can say, hey, just give me the changes since last Friday or a month ago or an hour ago, all that sort of thing. So really interesting. They also announced some cool like integration type stuff that's with OpenSearch that I think is pretty interesting recently. So last complex filtering option, hey, if you need to, look to that external system if you must. But again, keep it small. Make sure you know what you're signing up for and evaluate that carefully. All right, so let's summarize this, get out of here. We've got a minute left, so any questions we'll have to just do outside. But key takeaways that I want you to have from this is like, hey, Dynamo really is unique from other databases. I hope like some of that stuff around knowing your domain and doing the math, like that math is that can be hard to do with like a relational database or other databases with a query planner where there are so many different factors that affect your performance and costs and things like that. Dynamo, I think, makes it really straightforward. Also, that multi-tenancy architecture is really helpful as well. make sure you really understand the core API operations, especially those single item actions, that query operation. That's going to be the bulk of what you're doing in Dynamo. Make sure you know your domain. You're a little bit of the query planner now. You're going to have to do that sort of thing. Do the math. Reach out if you want help doing the math. I think it's a lot of fun to do these things. Handle your write operations appropriately, right? Structure your items so you can use those condition expressions really well. And then finally, Dynamo integrates well with supporting systems. 20 seconds left. Hey, thank you all for coming. I really appreciate it. Any feedback you want to leave in the survey, that'd be great. Anything else you want to say, come find me. I'm available on Twitter, email, all that stuff. Hit me up. Thank you.